Okay. Well, thank you everybody for coming to the. It's not the first annual, but it's the kind of the renewal, the revival of GCP Meetup. It's fun for me because I actually spoke when this was still being hosted way back 4 years ago in Salt Lake, and I talked about Firestore, our secret management system. So this is kind of fun to come back and revisit all that and be in this meetup again. So just a couple bit of, if you're not aware and you don't have interest lines, but I host a lot of meetups and stuff. We're being recorded. These little boxes above your head are really, really good. We'll pick up your whispers. So if you not want your whispers on the recording, and I'm serious about like, it'll catch every sound, probably too. They'll eat, but just be warned, they're really good mics. Other than that, I'm gonna go ahead and get started. So thank you for coming. This is Leased Logs, saving money by saving fewer logs. And I got to go back to the slide. So if you don't know me, my name is Carson Maxey. I work here as principal engineer at Leased. I'm on the developer experience team. You can call us platform engineering, you can call us DevOps, you can call us SRE. All the names, in my opinion, are just different, I think, for the same job. My team works to build the substrate that weave upon which the product is built. Right? So we do own a couple of pieces of the product, but mostly what we do is we build tools that our developers use to get things shipped. And we also maintain, as part of that job, a core library. So we do a lot with observability. We're not the only ones doing stuff with this, but we're kind of the developers. One of their main connections into logging and observability metrics, tracing. The logging was in my purview. And talk a bit about what lease logging is and go further on in. You can find me on GitHub at Firestore. That's important because this talk and the source code you're going to see, everything I do is always on there, Firestore. You can also find me doing the occasional too at Mastodon, Firestore at kind.net. So there's like kind of social. So let's go ahead and get into it. Actually, I want to talk real quick about Weave. This isn't going to work. So real quick, thank you, Weave, for hosting us here. And I bring this up to say that I'm not pitching Weave. Like, I work for Weave. They're really great to host this building here and other meetups. But none of the stuff in here is a sell for Weave or anything we've built. We're just a user of these products. And I want to share that with you. But do check us out. I'm going to also, again, I'm not here to pitch GCP either. It pitches itself. I'm going to show you really cool products that I think are useful and we build good solutions or a good solution. And I just want to do a really brief, in case you don't know what these are, we'll go deeper later, but we're going to use two GCP products in the presentation. One is cloud logging. There's not a lot I have to say about that. There are a lot of features, but at the end of the day, it's a logging platform. You send logs to an API and the place where you can go look at them. So if you don't know what cloud logging is, you can kind of guess. It's a web logging service. The other one is Firestore, and I bring that up because you may not have Firestore, and I'm going to reference it a bit before I explain it deeper. But at the surface level, what Firestore is a document-based, NoSQL database. It's got its kind of own ideas about how it should structure data, but it's a really useful, no infrastructure, globally available, high availability, like just nothing to run. Use it documents. So when I talk about Firestore, I'm talking about dealing with reading and writing documents in the Google API. When I talk about cloud logging, I'm talking about writing logs to a Google API to be viewed later. I'll go deeper in those. Those are the two things if you don't know things. This is kind of the plan. We're going to go over the problem with logs, what I mean by that, and the emphasis for the entire presentation. I will, very high level, talk about the logging architecture we had at Weave and have now, and what we were doing and why the leased logging made sense to us and how we solved the problem with logs here at Weave. I'll explain again what we had before. Then I'll do some incredibly brief primers on cloud logging and Firestore again. I've already explained the basics of what they are, but I'll point out the important parts of those products as it pertains to leased logs and what we're doing with both of those products in leased logs. I'm not going to spend some time selling them, but you'll see them in new content and kind of sell their stuff. And then finally, a big chunk of this is going through some sample code I wrote in a CLI. So I'm going to show you a presentation. We do leased logging with Weave. I do not want you to need all of the infrastructure we have at Weave to do leased logging. At the end, I have a CLI. It's just over 500 lines of code for the entire thing to do leased logging. There's this whole leasing idea with Firestore. You don't need all this infrastructure. You can do it right now. So I want to show that sample code demonstrate like these ideas don't require a lot of infrastructure to implement because it's all in GCP. All right. I just barely got back from a week-long trip to Redwood, so there's a lot of pictures of logs in the presentation because these are the biggest logs I can think of, and that's apt because when I talk about the problem with logs, I want to stress that I don't have a problem with logging. Right? I'm not a militant. I've met people that are really convinced that logging doesn't work, and it doesn't scale or it has certain problems. And I know of at least one company that says they don't even do logs; they just do traces with logs attached. They've made the choice to stop doing this. That's not me. Like logging, I grew up as a Python developer. Right? My first big boy job was writing Python, and I think there's debuggers for Python, but to be honest, I've never got one to work. And I was kind of my mentors, everybody I was working with, just printed things. And that's how they figured out what their code would do. And when you get used to printing things to code is doing, you really small steps logging. So I do a lot of logging. I still do print line debugging. And I like logs. It's really, really useful to kind of get a feel for what an application is doing. So when I say the problem with logs, what do I mean? And there's really one problem with logs, and when it pertains to logs at a large company, and that problem is scale. Right? The problem with logs, and you can talk to much anybody who's worked at a medium to large size company, and they will tell you, yes, our problem with logging is scale. It costs a lot of money for us to send a log. It costs a lot of money for us to use a logging service, to store them, to query them, because it's really easy to have a lot of logs, really, really quick. One of the main problems with scale of logging is that the cost of logging and the nature of like the usage of logging means that as you onboard more customers, the more your product gets used, the more logs you sit. So it's this pretty much linear growth of how successful you are with how much you're paying in logging. Right, where I had somebody recently say, like, yeah, I can probably just assume that you probably have 10% of your revenue just going to observability. And they said observability, but the logs are a huge part of that. I've worked at a lot of companies where it's just the logging bill is massive. It's the more customers you get, the more logging you do, the more money you spend on logging. So that's the problem. It's scale. It grows sort of linearly with your usage. Even if you're not worried about money, this is bandwidth. Think about how much you're worried about data you send over your APIs. Think about how much data you send for logging. It's probably 10x the amount of data you're responding from your APIs. So you may not be worried about the cost, but there's a lot of money spent sending logs out to a service to record and see, especially if you use some sort of service that sends it over the internet. Right? It's a little different if you've got this homegrown logging system where it's all inside the network. But as soon as you're going out to the internet to do logging, like that's significant bandwidth for things that honestly aren't used. That's kind of the other problem I don't have on this slide is I've worked a lot of places where they spend a lot of money and time and effort keeping all of their logs, and then find out that people just aren't looking at them that much. This is a lot of time and effort and money for something that people really don't use that often. So how do you solve this problem traditionally, right? All these are ways to do it. You just pay our work companies like, yeah, we just have huge budgets for logging. We think we need logging all the time. We need to keep all our logs all the time. So we'll just pay all the money to some provider. I've worked at places where they really look at static analysis of code, logging budgets for different products, and say you're logging too much, you've got to cut it down. So you kind of sit there and really be involved in the logging process to try to keep your cost and usage down. Also, like I said, just not log at all. Say logging's painful for us, and we're just going to not do it. Sidestep the problem, or maybe we'll print them out, but we send them with our partner. You can only view them while they're happening. But I don't like any of these solutions. And years ago, the management team came to my team of leads that we're trying to reduce bottom line, we're trying to save money. And do you have any ideas? And I looked at logging that we're paying for already. I looked at planned growth. I said, I don't want our log costs to scale with our growth. But I don't want to do any of these other things either. And I have this idea that I think is going to work. And it's leased logging. So very late, we're finally getting into the actual meat of this presentation. And this is a different idea that has worked really, really well. So this isn't just a theory. This is something that in practice been very successful here. And there's really one idea. Send logs conditionally, right? In the middle ground, instead of leasing logs, instead of paying all the money, you just set some rules and say, we don't always send all the logs. It turns out a lot of the logs aren't meaningful to most people. Really a fraction of logs really need to be stored here. So what we do is we really set a couple conditions. We say, all right, we're going to send the logs and store them to the cloud or whatever your logging platform is. for the first 15 minutes. Draft comes up, you got 15 minutes, everything you send is going to get persisted for whatever the duration of the logging platform has to keep your logs. After that, you will get a log if you have an active lease. And the lease is just a document that says, oh yeah, for this deployment of this application, I do want logs saved. Log leases are meaningful because there are conditions. And the main question that comes up when I introduce this is, what am I trying to do about the problem that only happens occasionally, right? I've got a service offering abroad. 1 out of 100 requests that happen a week have this problem, and I need the logs figured out. You say, that's fine. You can use a tool in a second to just say, forget these rules. Save all my logs for this service for the next hour or for the next 3 days. You let people lease logs for up to a week. That basically means, yeah, you turn it on. From the moment you get that lease, all the logs that your service sends start going to the cloud. And I mean the moment. There's no redeploy, there's nothing else. It's basically instant. We'll see that in the demo. So lease is active, or you have a couple of different log levels. So error levels inside it always need to be shared. That's important to track errors that are happening. And then there's a special function that we wrote in our logging libraries. I have a custom log level of always. And again, the logger just says, oh, if it's an always level, then I can always send it. So we do give people tools for leasing logs or having special logs that they think need to be durable. And that's it. Those are the 4 tools and works. So let's talk a little bit about how logging at Leave works and how we fit this whole idea into our ecosystem without changing what our developers do. So before lease logging, this is it. This was a vast simplification, but this is generally the idea. And there's a little bit of a story behind this logging sidecar that might seem a little weird to people, but it turned out to be very useful for us. The way that logs get sent to standard out and to the cloud for Leave is that our developers write code. They just write logs like normal, they don't know the difference. But what happens is when they deploy that to the Kubernetes cluster, that logging library actually sends a GCP request to the sidecar. It's just a container sitting there, gRPC request to a logging sidecar. It's just a container sitting there, listening over gRPC, receives all of the incoming logs from the containers, and does stuff. Now, you might ask, why not just print standard out? I've heard of the 12-factor math. The rules in container land is you just print logs standard out and let the cluster go. The answer is when we first did this, we deployed on Kubernetes from the very beginning, and it was all homegrown clusters, and they straight up didn't have the facilities on these early homegrown clusters to scrape all the logs from the nodes and aggregate them together and ship them. Right. So it's just, and they didn't want to build that, so we did this easy thing of we'll do a sidecar. The sidecar will have all the logic for sending things, and we don't need to scrape it. That's not true anymore. We're on GKE, and we could theoretically just print out, but we actually turned out to really like the sidecar model because when we wanted to change how logging works to implement these logs, we did it without a code change. We just did it by changing this version of the sidecar we gave you on the board. But that's it. You send logs, it always goes to standard out, and in the early days, it always went to GCP. This was the whole ecosystem. This is what our developers. This isn't accurate code. We developers here, you can be like, that's not function. I've simplified it for the purposes of demonstration. But there's 3 logs in here. There's an info, an error, and another info. And this is some sample code that we use to illustrate what it looks like if a Leave developer to run this code. This is what they would expect from the app when it's deployed. Right? So there's one way for them to view logs, and this is with the developer CLI. So we have the developer CLI that's the first place developers go to do a lot of things to get their job done. It's called BART, and there's a subcommand in here called logs. And the dirty truth about BART logs command is it just runs the kubetail for you. It just gets some data and runs kubetail behind the scenes. And if you don't know what kubetail is, it's essentially talks to the Kubernetes API, finds all the things that are places where your app is deployed, given the criteria you run the command with, and interleaves them with this nice color code. So developers, before we did these logs, would just run BART logs, and they'd see all the logs of all their running services live, and it would stream in as they came, and it would be color coded and aggregated. And it's really useful. The downside of this is that once the containers are gone, these logs are gone. Right? These only are available while your thing is live. But useful in picking this log. Another way to do this before these logs is they go to Argo and they just go navigate to a container or a pod and view the logs live in the Argo URL. It's still coming from the Kubernetes API. These are just different ways to talk to Kubernetes. And they got all the logs all the time before these logs. The last way developers would get logs here is with the GCP cloud logging. Right? So they go in, We shipped all these to the cloud. You go to that cloud service and you can query all of the logs, all of the containers, whatever they've ever sent. And if the container dies, this sticks around, right? Because this isn't coming from Kubernetes anymore. It's now persisted in somebody else's API. So this was really useful, but it wasn't used that often. It's just often faster just to go straight to your thing that you have, and you're trying to debug a live issue. So this is other view is historical, but this is what happened for all these things. So summarize, we've got 2 different ways of getting logs from Kubernetes. Those are ephemeral. Let's go away. The logs are gone. We have this durable one. But people mostly use the ephemeral. Now let's talk a bit about leased logging and how we took this old idea of, you send all the logs and they always go to all of the places. They're always in Kubernetes while the container's active, and they're always sent to GCP, and we just bear the egress and the costs of them. So we want to save money. We want to implement this logging thing. It turned out to be really change here at Leased. This is almost the exact same diagram, but we brought the Firestore. So we took that logging sidecar and we wrote a feature into it, and then you'll see it's very code. I basically copied that feature into the sample SDK at the end. And the logging sidecar would start up, start a timer. I'm going to guarantee to send everything to GCP 15 minutes for the first 15 minutes of me being up. After that, it's basically watching Firestore. Say, okay, I'm going to go to Firestore. I'm going to find the collection called leases. So there's a collection of documents in Firestore. We'll go into that in a bit. Called leases. I'm going to find the lease that matches my app, and I'm going to watch it. And if that document ever gets created and it has an expired time in the future, and you'll kind of get the idea for this to be the demo, then I'm going to turn on logs, right? So essentially, you're just watching for document changes to turn on the feature. And developers just run Bart log lease, this stuff command, and it would say, okay, how long do you want logs for? And all its job wanted to do was write the document. So no infrastructure on one part, very few document reads and writes, which essentially made this free in the Firestore for us. And developers could very trivially, with no questions asked, these logs as long as they want. I've even said you can go up to a week at a time with Bart command. If you want to go even higher, if you want to log in every other day, at least for another week, and if effectively have all your logs in all the time, I won't stop it. I haven't needed to do that. In fact, it turns out most people don't even lease logs ever. They're happy with the first 15 minutes. You'll see why in a second. But this is the whole ecosystem built. So, what did this change in the developer experience mean? Well, their code was unchanged, right? They didn't need to build this because the sidecar didn't do it. So if they were to deploy and get a new version of sidecar, they're done. So they direct the same code they always run. Kubetail, Bart logs, however you get logs from the Kubernetes API, that didn't change. Because we always print standard out, right? Send us all the logs, we always print them, because that's very cheap comparatively. So Bart logs experience didn't change for developers. Argo logs didn't change for developers, right? It unchanged. You get all the logs you always got before these logs, because this is from the Kubernetes API, we just printed out for you. What did change was pretty minor. This is kind of a before and after comparison. And you used to get all the logs all the time sent to GCP that stored months or whatever it was. Now you only get the first 15 minutes, or after that error, or always level logs. So it'll still persist like in all rules, but it's just you get a much smaller subset in this exact view. And that's the only thing. This is why the main reason why it's been so well received is we didn't interrupt most of the core development. We kind of interrupted this thing where you need to view aggregated logs after those. But it is a really minor change for developers. So hopefully we all are going to fail for, like, it's generally actually a really lightweight system and a really lightweight impact, but it has huge implications for cost and egress. So that being said, let's go ahead and go into, like I said, I'm going to do very lightweight pointers on cloud logging, just what you need to know about cloud logging for the demo, and then we'll do Firestore and we'll do the demo. So if you haven't gathered already, I already kind of talked about this a bit in the intro. Cloud logging is the GCP provided service. You don't have to run any servers or anything yourself. It has a pretty good free tier. I think each project gets, I looked it up, 50 gigs of data a month of logs, which is a lot of logs. Easy to surpass that at a large company with a lot of, but it's pretty free, and it's why the demo doesn't cost me anything, and the repo has Terraform and the whole thing for you to go spin this up and play with this yourself. You have to attach to it to get Firestore enabled, but we're well into the free tier of both of these for the. It has its own structured logging. It has this thing called log routers that are bolded because if you're trying to solve logging costs, one other way to do this might be with log routers, and I'll show you a screenshot, talk about that in a second. And other than that, it's just investigate. Just post logs and then go into the console to look at them. It's not a I mean, I'm sure there's some details here, but it's not a complicated product. I said I talked about routers. If you're trying to save money, one of the ways to save money on logs is to send fewer logs. Another way is to, when you send them out, have the system persist them to places that are cheap. The default is what's called the logging bucket, which makes them available in the normal log explorer, makes them really queryable, and you can do a lot of really cool stuff really quickly because they're kind of hot and ready. But you can target logs that have certain attributes. There's actually logs criteria, but you should come in here and make log routers and say, okay, yeah, bring in all the logs, but all the ones that are this level or below, put those into a bucket. These places that are really cheap to store logs as I want, but more expensive when I need to query them. Right? So if there are logs that you need to have for auditing purposes, you could still save a lot of money by just instead of extending all of your logging to be for 2 years, whatever. You can target your audit logs and shunt them somewhere where, when the time comes, if the time comes, you need to look at them, it'll cost you, but until then, it doesn't cost anything. That's a nice easy drop into leasing if you didn't want to do leasing. So that was logging. Now we'll do a primer really quickly on Firestore. So, like I said, Firestore is a document-based NoSQL database hosted by GCP. It's not Firebase, to be clear. There's this whole giant suite of Firebase products that are built for mobile and web and all these other things. And inside of that is Firestore, formerly Cloud Data Store, that is just this NoSQL database. You can use that by itself without any of the other Firebase stuff turned on. And we do extensively. It admittedly has some downsides when you're accessing it on the server, mostly around permissioning. I won't go into that, but it's got really robust access control system. If you're coming in using web browsers, mobile clients, but you're coming in from what they consider server-side languages, which is Go, in my case, it's all stuff we write. They don't have super robust permissions. They have read, write, entire project. So hopefully someday that'll change and they'll have some more robust permissioning, but for now, we deal with that. But it also has really generous feature, so generous that even here at Weave, a whole bunch of the ways we use Firestore, we don't pay anything still. It fits within the free tier. We're judicious about our use. We have some use cases where it's a couple $100 a month, but compared to the alternatives, that's still way cheap. So it's really nice system. I really like that it's not JSON based as well. So I put it in here. It's not like mobile. There's no JSON involved. It's got its own serialization that happens. Maybe there's JSON back, but I never write anything in JSON in Firestore. In fact, in Go, big surprise that Go and GCP work really well together because it's almost like working just with memory. It's really easy to integrate Firestore. You see that in the thing. About the color feature. The number one reason we use it a lot on the developer experience team here at Weave is this live watch. I love writing anything where I can do event-based programming. So I love writing Kubernetes operators because Kubernetes APIs can be event-based. And the same thing with Firestore. You can have Firestore client connect up to a single document or a subset and say, feed me the documents as they change. And it's pretty much real time. And that makes for a really nice developer experience to be like, instead of polling in every 5 seconds or whatever, checking some API to tell you the moment that your build is done, like that's a really nice feature. And you'll see that in the lease logging. Like I said, developers request a lease, it goes live in the actual deployed containers instantly. They get that event in real time. So that's the killer feature for me. Another feature that's appropriate for this meetup is that it will do automatic cleanup for you. So if you've got jobs, you're creating a lot of documents kind of ad hoc, and you would like something to clean them up so you don't have them to build up forever, there's a cleanup job you can make in Firestore that says, here's a field in my documents that I want that describes when they should go away. Please make that happen so I don't have to run a server to do it. So that's a really cool feature. The last thing I'll say is, if you're going to use Firestore, it's really rigid. Learn to live with this and learn to accept it. You have to build your Firestore database in the structure of collections and documents, collections and documents. They did this, and they built all their features around this. And if you work with this, you'll have a great time. If you work against this, and you'll have queries that don't work, you'll have a really bad time. So you have to understand this. I can talk all day. But it kind of forces this recipe to find. You'll notice you have a users collection, and you might have user one, and collections are just names. They don't have data. But your documents have actual attributes. What's neat though is documents can have sub-collections attached to them. And those sub-collections can have documents, and those documents can have sub-collections. So you end up being able to really easily, for example, watch all of the phone calls that are coming into user one's home phone number by just watching this sub-collection of user one phone's home history. Right, so you can use that watch just to stream live data in this really, really useful way. You can see why it's so great for mobile apps and other really responsive apps. We're not going to do anything that fancy for the demo. You do this, which I recommend if you're new to Firestore, you probably want the latter first. Try just a collection and see how far you can get. Don't go crazy with sub collections until you really need. So we're going to go find a leases collection, and we're going to make some leases. And those leases have 3 fields. And Firestore is strictly typed, right? So it's not JSON, and it supports types that JSON doesn't support. So it's got a native timestamp type, and it's got stuff. So we're going to have leases that we make that contain an expire at, a reason why the lease exists, and who made it. And that's the whole demo and this isn't that far off from the actual documents we have here for log leasing. Now we're going to get into the home stretch here. I'm going to go really heavy on sample CLI. I think it's really cool. Like I said, probably talking about more than it'll take me longer to talk about it than you probably will for you to read it, because it's just barely 500 lines of code. Like it's small to do this item. So we'll cover a diagram of how CLI fits what we've seen in regards to log leasing. We'll do a really light code tour. I'm going to only touch on like the core part of the CLI, and then do the demo where it really comes alive. So this will look a lot like the diagram we do at Weave, because it's pretty much the same thing. I've just simplified this down to something to run on your machine. We're going to build, and I already have a leased log CLI. And that CLI has 4 subcommands. It's got lease extend, lease expire, capture, and slog demo. So the extend and expire do what you might think. They just write Firestore to either update, upsearch a lease document or delete. That's all that the CLI has to do. It's very minimal interact with things. Then it's got these other 2 commands. It's got the capture command, and these 2 hyphens are on purpose. The capture command allows you to have the CLI execute any other command that you want and capture the standard out and standard error to basically things that command prints and ship them to cloud logging while obeying the lease. So any command, take the CLI and use it to run your service today and start doing lease logging if you want to. I don't know if I'm exactly right, but it's solid code. And finally, the test log demo will show you how you can do this whole lease log thing if you wanted to just directly build it into your Go tools. I'm doing it for Go because I like Go, but gives you the idea of how to do that without needing to have something in the middle. But they all obey the same thing, right? It watches the lease, and it ships logs always to standard out, so it always prints, and then only sometimes it send the logs to cloud log, saving money. So it's a diagram. Going into the code, I'll go, if you don't know, I'll go over kind of the key points of what's happening here and show you it's not a lot. So first chunk at the top makes a logging client to talk to GCP Cloud Log that uses your default application credentials. That's what it's going to use. You have to have had gcloud on your machine and set up the application credentials, but it'll detect these if you run it in a VM or a container, do the normal detection of credentials. So it makes a logging client to talk to our test. It then makes a Firestore client to talk to our test function. Both of those will error the CLI if you can't do those. It does this really neat thing that is kind of unique to Firestore, where it makes a document. Here's what you see in this third section, where we get a reference to the collection of leases and a reference to the collection to the specific lease we're trying to interleave. And the doc ref actually contains a pointer back to the client. So if you give someone a doc ref and Go, the Firestore SDK, like they can update, delete, even create a doc. The doc refs to real things, it's ideas about what things might be. So you'll see the doc ref being used to just interact directly with the object. Then we're going to, of course, in Go, we're going to interact with so we make these structs. I don't know what it's like in other languages, but in Go, you make a struct and you just sort of send that to Firestore, and it converts the types, the Go types to Firestore types, and back and forth. So we have expire at using the reason. The main bulk, almost half of this CLI is this manager file and this manager struct. And we'll go over the details, but essentially its job is to keep track of the lease state and decide whether it needs to send things to the login. That's all its job is to do, is watch Firestore and know that the lease is on or off. And so the bulk of what the manager does is talk to Firestore. So when we run a watch lease, we give it the doc ref. Say, here's where the lease is going to live in Firestore. It may not even be there yet. Here's where it should live. And the manager's going to start watching it for events. There's a lot of stuff here, but really this kind of middle line, this third line down, creates an iterator. It's essentially the magic for fly watching. So here's a place where a document might exist. I want you to feed unto me snapshots of the document's data as they change. This big chunk here in the middle is just gracefully waiting for the next snapshot and exiting nicely if the app was just being closed in a normal way, or handling these normal errors by just returning. Moving further down in that code, when you check to see if the snapshot exists, which might seem a little weird because you got it, yet it can somehow not exist. And that's normal. If you start watching a document that doesn't exist, still get the initial events and it doesn't exist. Like that still notifies you of that initial state saying, yeah, that you asked for the document to this place and it's not there. So we'll check to see if it doesn't exist. If it doesn't exist, we'll make sure that we keep the lease on until the guaranteed time. That first 15 minutes, or in this demo, will be 5 seconds. After that, if we do have a document, that it does exist, we will make that go struct and we'll tell it to show the data in the struct. This is all it takes to serialize. JSON, there's no well, you just give it a struct and feed it. Once we've got that, there's an expire at the document, and we will tell the manager expire after that lease is over, right? So the main bulk of this code is really just getting all the Firestore stuff is just to get a timestamp in a kind of library. With that timestamp, we call the expire at function. And expire at is what essentially says, well, you're trying to get me to expire before my guaranteed time. Actually, no, won't let you do that. You feed me whatever you want. We'll always at least last the duration of that guaranteed time. It does some go stuff in this bottom chunk. Don't worry about this to clean up the timer, the clean link, which you didn't have to. Yeah, in new versions are going on this, but in this current version, you didn't. So the main chunk, once it's got that time, it says, okay, well, I'm going to, if the time you gave me is in the past and after my guaranteed time, I'm going to disable now. Otherwise, I'm going to set a timer and just turn off, right? So there's a lot of code in here to effectively say, thanks for the time. I will stop sending logs when that time is passed. That's all that's happening. That's the whole code for that. So let's go ahead and go to the demo where we get into the bulk of seeing this live, which is where I think it's the most fun. Let's do the whole talk. All right. I'm going to try to make them as big as I can. If I can make them full screen if necessary, if you can't see stuff, there's a couple places where it's really nice to see them side by side. So there's this README in the repo. I'll give you a link at the end. And in there, it has a section, you probably can't read it. It has a section at the bottom to make the project, you can Terraform yourself and do this yourself. But it also tells us how to do the demo. So the first thing we do in the demo is we're going to build our Go code into this binary, this test binary. And then we're going to do on one screen, we're going to run this exec. I'll actually maybe full screen this a little bit here. This makes it worse. Okay, so you can, I'll go over this. It's really hard to read and make it big at the same time. But essentially, we run the lease logs command. We give it the lease ID. We inject the lease ID into the thing at runtime. It didn't require it. But for our demo, we have to tell them this is the lease you should watch because I want to run multiple commands at once, different leases. So watch the demo one lease ID, and I want you to capture the command that I give you. This little double dash, if you don't know, is a Unix thing for it's a POSIX thing for I'm now giving this command argument. Don't try to read any of the things I give you as flags. I'm going to give you stuff. Don't interpret them as flags. They might look like flags to you, but just read them as a series of strings. This is really useful for when you need to combine complex commands together. So essentially, we're saying, run this bash script, and this bash script is just going to, in an infinite loop, print the date, sleep every for a second. That's all it's going to do. So this is my log generator CLI. This could also very easily be your own system. You'll see that in a second. So that's what we're going to run here. Second thing we're going to run is the extend command later. So I will full screen this, and we're going to just run this without, there's no lease that exists yet. In fact, let's go look at Firestore. If we look at Firestore, you see that there are no documents. Again, hard to see being safe on time. There are no documents, so it's going to start up, connect, get that initial event saying there's no lease, and say that's fine. I said the initial duration I need to send logs. So I'm going to run the not the run the one that actually does stuff. Okay, so hopefully that's here. We got this watch release print that happened at the start, and then we got a bunch of logs that were sent for initial lease duration, much shorter purposes, and then print lease expired. So again, just like with lease logs, printing all the time, but you would only expect the logs while the lease is active to be returned. So if we look at this, about 12/15/21, we disabled the lease. If I go into my log explorer, and I might have talked increase this time, run this. There it is. So we can see the logs. There's a diagnostic log that sent the system sends for us. But here it is, 12/15/21. We stopped getting, like, that's it. That was the whole lease system. The code didn't know. The code's just bash. It doesn't know about this, but it obeys our lease log. We can then run this extend command where let's clean that up. We imitate part logs lease, and we say, okay, extend the lease. I'm going to give you a reason why I'm extending the lease on demo 1. Hit enter, and you can see that it immediately found it. It might be a little slow with the refresh, but it found that lease and then it expired. And I can extend it again while it's going down here, and you should see it pretty quickly. There it is. So pretty much the moment I put the document up there, the lease is active, and I will see new time. So 12/16/43, it's going to show up here. The logs explorer, 12/16/43. So there you go. That is logs leasing with one CLI done with, where you can literally have a CLI call anything that will obey this lease cycle. To show you some GCP features that are neat, I'm going to refresh this Firestore. It's really fun to see this just on the UI. So I'm going to go this over and create the lease again, and you'll actually see the console live updates as well. So it's really fun to be able to go into just the console and see your documents change live. And I'm doing this a lot, but you could use this whole leasing system to turn anything on and off basically instantly if you program it the same way. Like it's just the logs, but it's a really flexible idea. I think I've really grown to believe that leasing is the only way we remember to delete things. There's no such thing otherwise. You get it for a while, then it automatically goes away, or it stays forever. Like, those are the two truths. So let's do the other demo real quick, and we'll call it done. The other demo is with the slog package, and I'll show you what the code looks like for that. But it illustrates some kind of more interesting stuff. If you want to code your program, your Go program directly using the same idea. So I'm going to run the slog demo. The main difference you'll see here is that it is much richer. It's got timestamps. It's got different levels. It's got metadata. I don't know if you can read this, but I've got each of these has their own key value attribute attached to the logs. But it watched the lease, and then go past it. There's a lot more logs. There it is. It expired. So every second, I've got some code, and I'll show you that. This is the whole bit of code that hard to do all this right here. So this is what the developer writes. They just use the normal Go structured logging package. They have no idea. All you do is you have to program at the start, just substitute the normal handler for a little special handler that talks to the manager and knows at least data. But the really cool part about this demo is, just like before, if I go back to my log explorer, I'm actually going to start a fresh one so I have new times. All right, so if I come back in to this demo, you can see you get something directly integrated. That's way more robust. Suddenly we start getting these color-coded log messages second. So here's your info warning errors being repeated. But once that log lease expires, I renew, and I keep refreshing this, all the info is warnings went away, but the errors kept happening, right? So it's the same thing we've done, but in the whole CLI, just over 500 lines. So the concept is easy to understand, easy. And we could extend the demo. I will for the sake of time, but we could also, well, let's just do it. We could change the CLI here and extend at least for demo 2. And you'll see links extended on the left, so they can interact separately because they're just different documents, and you just have the different processes looking for different documents. That's the whole idea. So, all that being said, we'll go back. Hopefully, you get an idea of these 2 really useful features out of GCP. So, I like cloud logging. I like logging in general. I just want to be judicious about how we use it and how we scale. And really like Firestore. Like, I think it's a very, very useful product. We could overuse it like any tools. I try to be not make it work, but it's really helped us solve a lot of problems in a way that is fun for the it's like it's really cool. I hate having to delay the meet because it is so cool to just have 2 terminals and watch them react instantly when you hit the enter on it. That is always fun. I don't know what else to think. I want to use Firestore. It's always fun. And like I said, the whole leasing system, I'm turning on and off. You can do the whole thing and swap out logging for whatever you want. Have an idea of this kind of dynamic leases you want to enable it to see. So that's it. The QR code link for this talk is right here. I do not have it yet, but if you go to, we've had an engineering blog that's here, go to the right, engineering.gitlab.com. I'll be posting, we do our wall engineering blog post there, and also post entries for all of the things that we do with recordings and information. So if you like this kind of stuff and stuff we've been doing, the stuff I'm doing, look there. You're not kidding, 5 of these about to pop up on that blog in the next 2 months. So I've somehow packed my fall with presentations. And that's it. Thank you. I will stop recording and never